After finishing the solving, mechanical will not show you any results by default. You must determine what you want to see or calculate, and mechanical will evaluate it. Don't worry, the evaluation of results is very fast, not slow like the solving process. So you can determine what you want to see after finishing the solving. You won't have to start the solver again. The solution section here on the left is where you will add the results that you wanted to be evaluated. I will start by showing the temperature distribution in the whole TEG. Right click on the solution, insert, thermal, temperature. This should show you the temperature distribution through the bodies or the surfaces you select. By default, you will find all bodies selected. Right click on this temperature icon in the tree and select Retrieve this result. This will evaluate the temperature distribution in all bodies. You will notice strange temperature contours. The temperature should be maximum at the hot ceramic and gradually decrease until reaching a minimum value of 27 degrees Celsius at the cold ceramic. But based on this color distribution, there is a maximum temperature of 537 degrees Celsius. Why is this? If you remember what I told you about the wire while we were setting the analysis settings, due to heat generation in the wire, it gets hot. The convection coefficient we used is not high enough, causing the temperature to reach 500 degrees Celsius. Anyway, this has no negative impact on the performance. But to see the contours correctly in the TEG, we need to deselect the wire. In order to modify the bodies selected to show temperature distribution through them, you need to suppress this temperature component first. Then select all bodies using Ctrl A. While holding Ctrl, click on the wire to deselect it. Then click Apply. Then unsuppress the temperature again and re-evaluate it. Now you can see the temperature distribution through the TEG without the wire. We do not need the temperature distribution in the wire itself. It is out of the scope of the study. You will notice that the mesh is shown on top of the contours. This may be annoying or irrelevant here. You can fix this by going to the Context tab. Under the Edges option, select Show Undeformed Wireframe. This will fix this issue. You can try different settings here and here to achieve your preference regarding displaying contours. If you want to remove the ceramics to see the temperature distribution, you cannot just unhide the ceramics. You have to create new contours without selecting the ceramic in them. Press Ctrl A to select all bodies. While holding the Ctrl key, deselect the ceramics and the wire. Evaluate the new contours. As you can see, now you have the contours inside the TEG. The next result we wanted to display is the voltage distribution inside the TEG. Right-click on the solution to open the Insert menu. This time go to the Electric submenu. The first option is Electric voltage. Similar to the previous contours of the temperature, select all the inner components of the TEG, the legs and the shoulders. No need to select the ceramics and the wire. Evaluate this result. Now you have the complete voltage distribution inside the TEG. You can see how the voltage builds up gradually starting from the ground, passing through each leg until reaching a maximum value at the last one. In addition to contours, we need to evaluate some performance parameters of the TEG. The first parameter is the output voltage of the TEG. Yes, we already displayed the voltage distribution, but now we want to calculate the exact generated voltage. Insert a new solution result and select voltage. But this time we will only select the wire surface, not the whole legs. Evaluate this result. Now look down here, you will find the exact value of the average voltage. Click on this small check mark to define this an output parameter. We will need this for future calculations as you will see later. Rename this result as output voltage. Next, the second parameter is output power. The generated electrical power from the TEG is consumed in the form of joule heat inside the load, which is a wire connected to the terminals of the TEG. Mechanical can calculate this joule heat directly. Insert electric, select joule heat. For geometry selection, select the wire only. Evaluate this result. You can see here the average joule heat generated in the wire per unit volume. To get the total output power, we need to multiply this value by the wire's volume. Before proceeding, I will rename this result as output power per unit volume. Renaming is efficient when we have many results to navigate between them quicker. Now to get the wire's volume, insert a new solution and select volume. Select the wire only. You will find the total volume down here. Check the output parameter icon. Rename this result as wire volume. These two parameters are enough. The next step, I will show you how to perform some simple calculations using these output parameters.